Why learn about the enol tautomer? Well, as it turns out, enol tautomers are important. Enol tautomer. I'll write it in all caps. Very important. Okay, so before we talk about why the enol tautomer is important, let's look at our good friend, the enolate. So the enolate, of course, I'm just drawing a simple ketone. If we treat this with base, we can form an enolate. We've seen this many times before, both in chemistry 250 and 350. We know that this is a strong nucleophile. And as a strong nucleophile, what are we going to react it with? Well, we will treat it with weak electrophiles, such as alkyl halides. We can react the enolate with alkyl halides. They need to be primary halides, but we can react it with alkyl halides, and that does an SN2 reaction. We can even react this with carbonyl compounds. Carbonyls are themselves weak electrophiles, and that gives us access to all the aldol type reactions, aldol condensations, aldol reactions. So this is what we do with the enolate. Now let's look at the enol. We can take a carbonyl compound, we can treat it with, in the presence of acid. Instead of forming the enolate, we really form the enol. Now, what is the enol? The enol is an alkene plus an electron donating group. This OH is an electron donating group, and so that makes the alkene kind of a supercharged alkene. It's a very electron-rich alkene. Why is it so electron-rich? Well, because it has an extra electron donating group. Now that makes this alkene able to serve as a weak nucleophile. It's not a strong nucleophile, but it's a weak nucleophile. So what do we react with our strong nucleophile? Well, our weak nucleophile. Let's put a line here just to keep this clear. If nobody else, it's for my help. We need a strong electrophile. And what are good, strong electrophiles to react with these enols? Well, you can react things like halogen sources. We'll see a lot with this. You can also actually treat this also with carbonyls. Now, not really carbonyls, but protonated carbonyls. We won't go into this. But there's actually a whole branch of aldol chemistry that you can perform under acid-catalyzed conditions, and it relies upon forming our weak nucleophile, our enol, and reacting it with carbonyls. Instead of forming the strong nucleophile at the top of the screen, a strong nucleophile enolate, we generate a weak nucleophile. And the chemistry actually works pretty well. We won't cover that, but there's a lot of applications of these enols, and we're going to see a few of them. And so it's important that we understand that enols are not just, don't take a back seat to things like enolates. There's a use for things like enols.